Assalamualaikum and very good day to everyone. Okay, so welcome to our online session on chapter 4 energy balances. So I'm your instructor today, Madam Nur Alwani binti Ali Basha. So today we will focus on a very fundamental concept in chemical engineering, the conservation of energy principle. So energy is one of the most important topic in chemical engineering. Why? Okay, because it helps us to analyze how energy flow in and out of the process system. So without proper energy balance, we cannot design, optimize, or troubleshoot engineering process effectively. Okay, so what is the learning outcome from this chapter? Okay, so what you will to learn is you will able to describe the key terminologies used in energy balances. Okay, number 2, you may able to identify the different types of energy that exist in a process. And finally, you'll be able to explain and construct the energy balance equation for both closed and open system. Okay, so this means that after today's session, you should not only know the theory, but also be able to apply it into the engineering examples. So now let's move into our main discussion, which is the conservation of energy. Okay, are you ready, guys? Okay, so for the energy balance, we must know the foundations. Okay, so usually energy balance, the foundation is come from the first law of thermodynamics, which stated that the energy can change form, but is neither created nor destroyed. Okay, so in terms of the process system, this means that the total energy entering the system must equal to the total energy leaving the system, with adjustment for generations, consumptions, or accumulation inside the system. Okay, so in chemical engineering, a process system can exchange both energy and mass across its boundaries. Okay, so before that, we need to understand clearly the meaning of the system, surroundings, and also boundaries. Okay, because the process system, we have closed system, open system, and isolated system. So understanding the definition is very important. Okay, so what is the system? It is a part of the universe that we are focusing on, such as the content of the reactor or the steam inside the turbine. Okay, what is the surrounding? So surrounding are the everything else outside the system that can interact with it. For example, the environment, the equipment, or even the operator. Okay, so the boundary is an imaginary or physical surfaces that separate the system from its surrounding. So to understanding this definition is very important because energy and mass can only cross the boundary, not appear or disappear within the system. So this is accordance with the first law of thermodynamics. So now let's take this into example. So I have a bottle of perfume. So let's try to classify the system, surrounding, and also the boundaries. Okay, so when we have the this bottle, we can see that the system is something inside the bottle, so which is the liquid perfume lah. Okay, so the system is a liquid perfume. So the boundaries is this bottle. So what is bound the system, we call it as a boundaries. And so what is the surrounding? So surrounding means that the anything else that outside the system. Okay, so it's clear. Okay, so what we set up on the energy balance, we must carefully define the system boundary and identify what across it. Okay, so process system, it contains of closed system. You need to identify or differentiate between closed system, open system, and also isolated system, whereby the closed system means that they have the changes, the exchange of the energy across the system, but there is no mass transferred across the boundary. Okay, for example, the piston cylinder device. Okay, what about the open system? It has exchanged both energy and mass across the boundary. And the last one is isolated system. There is no exchange of mass and energy across the boundary. Okay, next, let's look at the form of energy that needs to be considered in energy balances. There are a few forms of energy. The first one is internal energy, where the energy is stored within the molecules, including vibrations, rotationals, and electronics energies. Okay, and then we can see that the kinetic energy, where the kinetic energy is happen due to the motions of the system. And the last one is the potential energy. So the potential energy is due to the positions or the elevations. Okay. So other form of energy is heat and work. Okay, so work is the energy due to the force acting through the distance, so such as the shaft work, interbeams, or the compressions in the pump. And the heat is the energy transferred due to the temperature difference. Okay, so depending on the process, some forms of energy may dominate while others can be neglected. Okay, so the general energy balance equations can be written as input minus output plus generations minus consumptions is equivalent to accumulations. Okay, so there are two types of the system which is written differently. So the first one is the closed system, where the equation reduced to the heat minus work equivalent to different in internal energy, while the open system we use enthalpy and write it as Q heat minus work plus the flow rates of the energy into the stream minus the flow of energy out of the system in terms of enthalpy. So this is equivalent to delta E, or we can see it as the accumulations of energy by time. Okay, so this is the form that most useful in engineering applications like turbines, pumps, compressor, and also heat exchanger. Okay, class. So this is the end of the presentations today. So to summarize today's sessions, first we begin with the first law of thermodynamics, okay, which is the basis of the energy balances. So after that, we look into how process system exchange both mass and energy across the boundaries. And then we reviewed the different forms of energy relevant to engineering analysis. And finally, we introduced the general energy balances equation and its application to closed and open system. So in the next class, we will apply this concept to solve practical energy balance problems. So please make sure you review today's material, as it will be the foundations for calculations in the upcoming classes. Okay, so see you again, guys. Thank you for paying attention to this class today. Bye. See you again.